Hello my dear friends, I welcome back you to my YouTube channel, that is Beginners Chemistry, where you can learn the chemistry in the easy manner. In our Beginners Chemistry, we are going to start the one very new lecture, that is what, and it is a very important lecture for our class 12th, and the chapter name is the solution. By hope by seeing the background pic itself you got to know. But once I want to give you one good suggestion for you. If you want to understand the terminology and the concept and the application part of the solutions, better listening to the basics. Whatever the class we are going to deal, this class will helpful for you to understanding the terminology of the question and way to approach to the question. So any chapter when we are starting, the starting basics of the chapter, understanding the basics of the chapter is key role, and it is a very important while solving the questions. Many of the students, what they will do, you first they will directly skip into the topic. They will skip the basics which we are going to give. So by that what they will happen, what are the notations they have given in the question, that terminology whatever they are going to ask, they will get you somewhat difficulty over there. So listening of the basics is very important. Okay, now better we are going to start our class. Now we'll see. Now we are going to start the chapter solutions. Okay, now here what is the basic definition of the solutions? Solution is when two or more chemically non-reactive substance are mixed, they form a mixture is called solution. Okay, now what is the basic definition of the solution? When a two or more chemically non-reactive substance mixed, they form a mixture is called the solution. Here what is the mixture? What is a mixture? And mixture has been divided into how many types? Clear? Now we'll see. Here you can see, here the mixture, when the two or more non-reacting substance are mixed, they are forming the mixture, right? Here the solution, it is forming two types of the mixture. What is? One is homogeneous mixture and one is a heterogeneous mixture. So what is a homogeneous mixture, sir? Homogeneous means uniformly mixed. So whatever the solution we are going to see, that is our solution is a homogeneous mixture. What is the meaning of the homogeneous? Means it is uniformly, it is having the same phase. Clear? Now you can see here what is the meaning of the homogeneous mixture and what is the example. Let's take, I was taking the well-known example for you, that is PCl5. PCl5 gas is converted into PCl3 gas plus Cl2 gas. Clear? You can see uniformly all the phases are same. Clear? Now in our solutions case also, you can see this is salt. Salt is in the, now it is in the presence of what? Solid. Now this is our water. Now it is in the presence of liquid. If I add this salt to the which one? Water, what it is happened? This salt has become uniformly mixed in the solution, right? Uniformly mixed in the solution means this in this solution the particles which are present, we cannot see with our eyes. See why we cannot see with our eyes? Means that particle size in the solution is around 1 nanometer. The particle size in the solution is how much? 1 nanometer. That's the reason homogeneous solution particles we cannot see. Clear? Now comes to the if suppose if it is formed the heterogeneous mixture. What is the meaning of the heterogeneous mixture? Now you take the sand and water. Sand is solid and the water is a liquid. Clear? Now if you add the sand in water, if you stir it also, some part of the sand may be dissolved and the remaining will be settled down in the solution as a PPT, right? Now you can see here liquid is in the liquid phase, water is in the liquid phase and the sand is in the solid phase. Means heterogeneous means we are having the two different phases. What? Two different phases. Example, if you take the calcium carbonate solid, what it will convert? CaO solid plus CO2 gas, right? CO2 gas. Clear? Means here we are having the what? Two different phases. But this heterogeneous mixture we can see with our eyes. We can see with our eyes. But homogeneous particles we cannot see with our eyes. We cannot see with our eyes. Clear? Now, next we are going to move depending upon the type of the solutions. Depending upon the type of the solutions. Now here we are having dilute solution and the concentrated solution. Dilute solution and the concentrated solution. So when we can say it as a dilute solution and when we can say it as a concentrated solution. You see, dilute solution we will represent it as a dilute and the concentrated we will represent in this manner, COL. Clear? When we can say the dilute and when we can say the concentrated, you can see less amount of the solute and the large amount of the solvent. Sir, what is the meaning of the solute and what is the meaning of the solvent? Now comes here. Clear? Here this is salt. This salt is our solute. Clear? Now this water is our solvent. This water is our solvent and it is giving the solution. Clear? Now here I will explain very clearly what is the meaning of the salt and what is the meaning of solute and what is the meaning of the solvent and why it is giving the solution clearly. Now comes to the here. If a solute amount is less and solvent amount is high, that is a dilute solution, and the amount of solute in this, the amount of solute in the less amount of solvent. Clear? The amount of solute is somewhat high compared to the solution is, that is a concentrated solution. Better general example for you and our daily life example for you. What is the daily life example for you? If you take the which one? Lemon. If you take the lemon when you cut it and if you squeeze it, what will happen? From the lemon whatever the juice it is coming, that is concentrated. Because it will be highly concentrated. I mean, like, just to make you to understand, I'm saying that is concentrated. For that one, if you add the water, what happens? Its concentration level will be decreased and that juice solution will be the dilute solution. Clear? Now here, now based on this, here the next we are having going to see here types of solution on the basis of number of components. Now solutions are on the basis of number of components. Solutions are first one is a binary solution. What is the meaning of the binary solution? Here solution having two components. The two components is known as a binary solution. Clear? Next, if suppose ternary solution. What is the meaning of the ternary solution? It is having the three components. Next, third, if I say quaternary solution, what is the meaning of the quaternary solution? It is having the four components. Four components. Clear? Now, type of the solution on the basis of the number of components. Type of the solution. Here mainly in our chapter, mainly we are going to deal with the binary solutions only. We are going to deal with the binary solution only. What we are going to deal? Now I will explain. Clear? Now, before going, I want to make you to understand what are the different types of the solutions we are having. What are the different types of the solutions we are having? Now you can see, first is unsaturated solution. What is the meaning of unsaturated solution? You can see here, here this is our one solvent. Okay. Now here I was taken a one solute. Here I was taken a one solute. Okay. Solute means the one which contain lesser amount in the solution is a solute. The one which contain larger amount in the solution is called the solvent. Now here in this solvent, when I was adding the solute, this solvent, what it is doing, it is dissolving that solute. It is dissolving that solute. Then the type of the solution, we call it as a which one? Unsaturated solution. Unsaturated solution. That type of the solutions we call it as a unsaturated solution. Now you see here, when it comes to the saturated solution, means whenever if you are adding the solute to that solution, but that solution what it is doing, it is not able to dissolve the solute. And that type of the solution we call it as a which one? Saturated solution. Clear? Next comes to the supersaturated solution. Becomes unstable and the crystals will be formed. Sir, by seeing these pics, we did not understand very clearly, sir. Okay. Now I will explain with the very clearly. Now you see what is the meaning of the saturated and what is the meaning of the unsaturated. Better I will take well-known example for you. Here I was taken one solvent. Okay, water is our universal solvent. Water I was taking. Okay, this water maximum to maximum, let's suppose it can dissolve 30 moles of the solute. Okay, 30 moles of the solute means 30 grams of the solute or 30 moles of the solute it can dissolve. Okay, first I was added the 10 moles of the solute I was added. What happened? It will dissolve. It will dissolve in it. Clear? Then when 10, if I was added the 20, still it can dissolve. Then we can say this as a unsaturated solution. When if I add the 20 mole also. Okay. Next comes here. What is the meaning of saturated solution? Clear? Before going to understand the saturated solution, now I will give you one term. What is the meaning of the term? First is distillation. Clear? Now distillation is equilibrium with the crystallization. So what is the meaning of the distillation and what is the meaning of the crystallization? Distillation means solute is dissolving in solvent. Solute is dissolving in solvent is known as a distillation. What is the meaning of the crystallization? Reverse of it. Whatever the solute has been dissolved in the solvent, again it is coming into the solute, means again the crystal is forming. Here crystallization means solute is undissolving. Solute is undissolving. Clear? Again it is converted into the solute. The solute which has been dissolved in the solution, again it is converting into the solute. when the distillation and the crystallization has become equal or equilibrium. When the distillation and the crystallization both has become equilibrium, that type of the solution we call it as a saturated solution. That type of the solution we call it as a saturated solution. Now, here I was taking the water. Okay, here I was taking the one water. Clear? In this water, let's suppose 30 moles can dissolve. When I was added 30 moles of the solute, 30 moles of the solute when I was added in this solvent, what it has happened, you know, that 30 moles of the solute has been dissolved. 30 moles of the solute. When again extra moles of the solute if you add, what it will happen, you can see some salt is converting into crystallization. Again the solute which has been dissolved in this solution, again it is coming into the form of solute. Salt is dissolving. How much amount of the salt is converting into the crystallization? The same amount of the converted crystallization is converting into the undissolved. Dissolve and the undissolved. Here dissolve and the undissolved is happening at the same rate. Clear? If 5 moles of or 5 moles of the solute particles is converting into the solvent or it is dissolving in the solvent, the same 5 moles of the solute which has been dissolved in the solvent, again it is coming into the solute. Clear? That type of the solution we call it as a saturated solution. Clear? I hope it is clear for you. Now here next we are going to see, what in our solution we are going to deal with the which one? In our solutions we are going to deal with the binary solutions, right? We are going to deal with the binary solutions. Okay. Now in this binary solution, what we are having? One is solute and another is a solvent. One is a solute and another is a solvent. Clear? Now what is the solute here? Lesser amount present in solution. Lesser amount that present in the solution. Now what is the solvent? Higher amount that present in the solution. Clear? This is solute and this is a solvent. So how to identify the which one is a solute and which one is a solvent if suppose they have given? Clear, sir? If suppose water and sugar if you take, we can identify which one is a solute and which one is a solvent by seeing the quantity. Now how to identify that quantity? By seeing the quantity itself we can say which one is a solute and which one is a solvent. So what is that quantity? By seeing which quantity we can say quantity. By seeing the which quantity we can say which is a solute and which is a solute and which is a solvent. First is a mass, first is a moles. By seeing the moles we can say. Second, by seeing the volume. Third, by seeing the mole fraction. Clear? By seeing these quantities we can say which is a solute and which is a solvent. Clear? Now sir, better can you give or can you make it to understand with the one generalized example or with the question? Okay, I will make you. Now listen here. Here what we are going to see, we are taking the 20 ml of alcohol I was taking. 20 ml of alcohol I was taking. This has been mixed in the 50 ml of H2O. 50 ml of H2O. So by seeing the volume by seeing the volume, we can say which is a solute and which is a solvent. It's clear? By seeing the 20 ml, this is lesser, right? And this is higher. This is higher in quantity. So this one is a solvent and this one is a solute. Clear? 20 ml one is a solute and the 50 ml one is a solvent. Okay. Now let's suppose, sir, if they have given in this manner, if they have given 46 gram of C2H5OH ethanol, 46 gram of ethanol is mixed in 46 gram of H2O. If they have given in this manner, sir, here you may get a doubt, sir, here the weights are same. Here the 46 gram of the which one? Ethanol is mixed in the 46 gram of the H2O. Then how to identify here? How to identify here? Here to identify, what we have to do? We have to convert this into the number of moles. We have to convert this into the number of moles. From the number of moles, we have to see the quantity. Clear? Now, this is ethanol. Clear? This is 46 gram they have given. Find the moles. What is the moles formula? Given mass or given weight by molecular weight. Here, what is the molecular weight of the ethanol? That is carbon is 12. So, 2 carbons 24 and hydrogens are 6. Total 30. Then 24 plus 6, 30, and this is 16. Total 46. 46 by 46. And the number of moles of the ethanol will be 1. Now, when it comes to the H2O, number of moles of the H2O will be 46 by 18. 46 by 18. It will give you somewhat approx. What it will give? 18 to the 36 and clear? Now, somewhat approx it will give you somewhat 2 points it will give. Compared to the ethanol, what? H2O is having the high quantity in the solution, right? High quantity in the solution. So, here the H2O will be the solvent and ethanol will be the solute. Clear? I hope by this you got to know which one is a solute and which one is a solvent. But here one thing you have to remember. What is the key point you have to remember here? This is a very, very key point. Depending upon this key point itself, in the terminology of the questions also, it will make you understand and it will make you to understand the question very carefully. What is that one? Weight of solution. If they have given the weight of the solution, if they have given, weight of the solution will be equal to weight of solute plus weight of solvent. This is very, very important that you have to remember. Weight of the solution will be equal to weight of the solute plus weight of the solvent. Means weight of the solute, weight of the solvent equal to the weight of the solution, right? Means weight of the solution is not changing, it is same. But volume of the solution, if you write volume of the solution is equal to volume of solute plus volume of solvent, we cannot write. This is not at all applicable. Clear? Weight of the solution will be equal to weight of solute plus weight of solvent. But volume of the solution is equal to volume of the solvent. It is applicable. Only for ideal solutions. This is applicable only for the ideal solution, but it is not applicable for the real solution. Why it is not applicable for the real solution? In this chapter itself, I will make you very clear. When I was started the one concept called the Raoult's law, and there we are going to deal with the ideal solution and the non-ideal solution. For the non-ideal solution, why this weight volume of the solution is not equal to the volume of the solute plus volume of the solvent. There I will explain very clearly. Okay, this is not at all applicable and it is applicable only for the ideal solutions only. Clear? That's the reason weight of the solution will be equal to weight of the solute plus weight of the solvent. This is one key point you have to remember. Clear? Done? Now, Here next we are going to see notations. What is the meaning of the notations? These notations are very important to make you to understand the terminology of the question, or whenever we are solving the question, instead of writing entire name, we will use the shortcut or notation for that one. For that one, instead of writing, if I say what is the number of moles? Number of moles is equal to weight of, or given weight, given weight by molecular weight. Every time writing this entire time, it will make us, or it will take the more time, right? For that one, what we are doing, we are giving the notations. These notations you have to remember. So what are the notations that we are going to give in this solution, and this notations itself we are going to use in our entire chapter, or wherever we use that. For this solute, if I say this term or this notation we will use. If I say the solvent, this notation or the what, this notation or this term will be used. Now see, first one, mass of solute. Mass of solute or weight of solute. Mass or weight, both are same. Mass of the solute if I say, weight of the solute if I say. Mass of the solute if they have given, we are going to represent with the WB. WB, or in some books, if you are seeing any in the books also, they used to give some notation, they used to give the W2. So here we are using the WB. WB is represent for the mass of the solute. Clear? Or mass or weight of solute. Sir, mass or weight of which one? Solvent will be, we are giving it as a WA or W1. W1. Clear? Next we are going to give molar mass or molecular. Molar mass. Molar mass of solute. Molar mass of the solute will be B. Clear? Or M2. Clear? Or M2. Done? Next, molar mass of solvent. Molar mass of the solvent will be MA or M1. MA or M1. Clear? Now, here, now these notations I was given, right? Now, here you have to remember one basic formula. What is that basic formula you have to remember? That is number of moles. That basic formula you have to remember, that is number of moles. What is the number of moles formula? Number of moles is equal to given mass by molar mass. The same number of moles formula will be equal to given number of particles by Avogadro number. By Avogadro number. Clear? Given mass by molar mass is equal to given number of particles by Avogadro number. And next, if suppose, if the formula, if they ask in the form of volume, so number of moles will be equal to given volume by 22.4 liter. This is applicable only for ideal gas at STP. At STP. Sir, what is the STP, sir? STP means 0 degrees or 273 Kelvin. 0 degree or 273 Kelvin. Clear? Or 1 atm pressure. 1 atm pressure. Clear? These are the number of moles formula we have to remember. Clear? These are the Number of moles formula we have to remember. This will be helpful for us in the which one? It will be helpful for us to solve the questions. While solving the questions, it will be helpful for us. While conversions, here in the solution chapter, nothing it will be there. Very less formulas are there, very less concepts are there. But the only thing is we have to convert, interconvert from the molality to molarity, molarity to molality. In that manner, or mole fraction, in that manner we have to interconvert. Okay, I will explain how to interconvert, and there we are going to see the concentration term. There I will explain very clearly. Clear? Now, next we are going to see here in our NCERT, they have given the different types of the solutions. There you can see what are the different types of the solutions. Why? What are the different types of the solution? If I was added sugar in the solvent, sugar in the one water, then that will become which solution? Liquid solution. Why I was saying it as a liquid solution? Why I was saying? Because the solvent quantity is I. If the solvent quantity is I, now that solution also will become that solution only where the solvent, if the solvent is I, if the solvent is liquid, then it is a liquid solution. In this case, if you see, now if here I was taken one solute and one is solvent, okay, one is solvent. This solvent quantity is high. This solvent quantity is high. Then these two mix to give the solution, right? Then this solution will become liquid solution. Then this solution will become liquid solution. Then if solvent quantity, if the solvent is gas, clear, this solute plus solvent, and that solvent quantity is I, and that solvent nature is gas, and that solution is gas solution, and that solution is gas solution. If the solvent is solid and that quantity of the solvent is high compared to the solute, and that solution is a solid solution. Clear? There you can see here gas and solid. Solvent quantity is I. You can see here. Here the solvent quantity is high. Solvent quantity is high. That solvent quantity, and that is in the nature of solid. That is in the nature of solid. And the solution, what you will get? Solid solution. Now, solvent quantity is high, and that solvent nature is in the liquid. And the nature of the solution, we got it as liquid solution. Clear? Next, solvent quantity is gas, and that is I, and the nature of the solution, we got it as a gas solution, and the nature of the solution is a gas solution. Now you see, first we are talking about the gas solution. What are the gas solution? Gas, and the gas, it is giving the gas solution. Example, O2 and the N2, because in our nature only, right? Gas, nature is in the air. Air is nothing but homogeneous mixture of the O2 and the N2 and the many other gases. Clear? Next, liquid in gas. Liquid in the gas. What is that? Water vapor in the air, humidity, mist, chloroform vapors mixed in the nitrogen gas. Chloroform vapor that are mixed in the nitrogen gas are known as the which one? Liquid in gas. Next, solid in gas. Solid in gas. Clear? That camphor vapors in air are dust particles in the air and the smoke. Camphor vapors. What is the camphor vapors? Here we used to see the camphor is a solid. If you burn directly, it will be converted into solid, right? That vapors, it has been mixed in the air. Clear? Done. And the smoke also. In the smoke, that air we used to see when the sunlight at the evening times, if you see, what will happen? Some dust particles we are going to see in the sun rays. You can see some. If you want to see whether once you observe when the evening time, when the rays are falling, in that we used to see some dust particles. Clear? That is also one example. Next, gas in liquid. Gas in liquid. Oxygen gas dissolved in the water. Yes, because our which one? Our water is dissolved with the dissolved oxygen will be present in our water, right? Clear? That's the reason only aquatic lives are are safe in the water because oxygen will be present in our water. Clear? Next, liquid in liquid, that is ethanol mixed with the water, and this is a well-known example for us, and we are going to do one beautiful experiment on this ethanol plus water. Ethanol plus water, and these two will mix azeotropic. Sir, what is the meaning of the azeotropic? I will explain, and I will do one beautiful experiment on this also, and I will show it for you. Okay. Next, solid in liquid. Solid in liquid, that is sugar. Daily we used to sugar. If you mix it in the liquid, and it will become liquid solution. Next, gas and the solid. Clear? Adsorption of the gas over the metal and hydrogen. This is well-known example. Already we have studied about this one in the first year of the hydrocarbon, that is catalytic hydrogenation. What is the catalytic hydrogenation? Okay. Now you see. What is the meaning of the catalytic hydrogenation, Amma? If you take the one alkene, now this hydrogen gas, it will be adsorbed on the surface of the metals, right? Platinum or the palladium, and it will give you the what? It will convert that alkene into the alkane, right? This is a one metal surface. Now hydrogen gas will be adsorbed in this manner. Clear? Now this is a example for the adsorption of the gas over the metal. Next one, liquid and the solid. Clear? Amalgam. This amalgam, what is the meaning of the amalgam? Clear? Here you may get a doubt. Here if I was saying, what I was saying? I was saying Na solid plus Hg liquid. These two combines to give the sodium and the mercury amalgam. Here if I ask, in this amalgam, which is a solvent and which is a solute? Which is a solute and which is a solvent? If I ask, this Hg will be the solute and the sodium will be the solvent. Clear? Alloy. What is the meaning of alloy? Alloy is a mercury with other metals. Clear? Now if suppose if I ask zinc solid plus Hg liquid, it will give you the zinc amalgam. For this zinc amalgam, if I ask which is a solvent and which is a solute. Clear? This Hg is a solute and Zn is a solvent. Clear? Is it clear? I hope we have cleared about the which one different types of the solutions that we are having. Now next very most important that we are going to see, what we are going to see and what are the important thing that we are going to see. Now next, these are very very important. We are going to see, that is a concentration terms. What we are going to see, that is concentration terms. Before going to start the concentration terms, what are the concentration terms and why we are going to study this concentration terms? Because concentration so what are the concentration terms and what we are going to study in this concentration terms? Now we are going to see. Here in these concentration terms, we are having what is the concentration in this solution, nature of the solute. By changing the nature of the solute and the solvent, the concentration of the solution is also changing. Now what are the concentration terms we are having? Before going to the concentration terms, we will see the definition of the concentration terms. Concentration terms are used to represent amount of solute and solvent in a given solution. In a given solution, the amount of solute and the solvent in a given solution, that we will be represent as a concentration terms. That it will be represent as a concentration terms. Now we'll see what is the first concentration term we are going to see. The first concentration term we are going to see, that is weight by weight percent. Weight by weight percent. What is the weight by weight percent? Now you can see first what is the first concentration term we are going to study? Weight by weight percent. What is the weight by weight percentage formula? Weight of solute in grams by weight of solution in grams into 100 This is known as the formula of weight by weight percentage. Weight by weight percentage. Clear? Now this is temperature independent. Temperature independent. Already I said you weight of the solute and the weight of the solvent will give you the which one? Weight of the solution. By the amount of the solute and the solvent combiningly giving the solution, right, means weight of the solution is not changing. With the temperature also, weight of the solution is not changing. Clear? This is very key point you have to remember. Now what I was said, volume of the solution will change. If you see the volume term, that is temperature dependent. If you see the weight term, and entire weight term it should be there. Clear? Weight terms, only if the weight terms are there, temperature independent. At least one volume term if you see, that is temperature independent. Clear? Done. Next one. The next we are going to see volume by volume percentage. Next one we are going to see volume by volume percentage. What is the meaning of the volume by volume percentage? Volume of solute in grams by volume of solute in ml by volume of solution in ml into 100 This is a weight by weight percentage. Clear? This is temperature dependent, because with the temperature volume will be changed. Clear? This is temperature dependent. Clear? Now sir, what is a weight by weight percentage and what is a V by V percentage? Sir, how to identify the weight by weight percentage if they have given in the question, and how to identify the V by V percentage if they have given in the question. Now you see, if suppose what is the meaning of weight by weight percentage if they have given in the question in that manner. So how to identify and what that it represent and what is the terminology of it. Now you see, here let's suppose they have given 20% weight by weight of NaOH in aqueous solution they have given. Clear? Before going to this one, what does this aqueous solution represent? Aqueous solution means here water is acting as solvent. Is known as aqueous solution. Okay? If the water is acting as a which one? Solvent, that we can call it as a aqueous solution and we will represent in this manner. Let's suppose if alcohol is acting as solvent, is known as alcoholic solution, that we call it as a alcoholic solution and we will represent in this manner, alcoholic solution. So these two key points you have to remember. If the water is acting as a solvent, that is known as a aqueous solution. If alcohol is acting as a solvent, that is alcoholic solution. Clear? Now, if suppose 20 weight by weight percentage of the NaOH in the aqueous solution, if this suppose if they have given, so what does it mean? What does it mean? So it is 20 by weight percentage means of NaOH in aqueous solution means, clear, means 20 gram of NaOH that present in 100 ml of solution, that present in how much? 100 ml of the solution, 100 ml of the solution that is present. If I ask, if suppose 20 percentage of weight by weight of NaOH in the aqueous solution, find the, if suppose if I ask find weight of solvent, if I ask to find the weight of solvent, how you will find? How you will find? That already I was given the one formula, right? What is the formula I was given? Weight of solution is equal to weight of solute plus weight of solvent. Clear? This is the formula I was given. Now bring the weight of solvent to the left hand side. Weight of solvent will be equal to, what it will happen? Weight of solution minus weight of solute, right? Weight of solute. Clear? Weight of the solution is how much? 100. Clear? Weight of the solute, this is 100 grams. Sorry, 100 grams of solution, not the 100 ml. Sorry, 100 grams. Okay. Now here 20 gram of NaOH that present in 100 gram of solution. Clear? Now the weight of the solution is 100 minus, and here it is a 20, and here it is a 20, and that it will give you the how much? 80 gram is the weight of the solvent. 80 gram is the weight of the solvent. Clear? Next to suppose second one, what we are going to see, what we have seen, if 30% V by V of C2H5OH in aqueous solution, and calculate volume of solvent, and calculate volume of the, which one? Calculate the volume of solvent. Calculate the volume of the solvent. What does it represent? What does it represent? It represents 30 ml of solute present in 100 ml of solution. Clear? Then volume of solvent equal to volume of solute. B represents the solute, right? Volume of solute, sorry, volume of solution minus volume of solute. Volume of solution minus volume of solute. Volume of solution is 100 and volume of the solute is 30, and it will be the 70 ml. It will be the 70 ml. Clear? If suppose 30 percentage weight by weight if they have given, directly what you have to consider, it is a 30 ml of the solute that present in 100 ml of the solution. 100 ml of the solution. Clear? Now next the concentration term that we are going to see. What is that? It is very important. Clear? Now if this concentration term, if you remember, if whatever may be the concentration terms question they may ask, directly you can do. Clear? But it will take more time to understand what is the terminology that they have given in the question, but I will explain and I will derive it. So try to remember this one. If suppose W by V percentage they have given, W by V percentage they have given. Clear? What is the W by V percentage? Means weight of solute in grams by volume of solution in ml into 100. Clear? This is a weight by v percentage. Now in this weight by v percentage, what is the density of the solution formula? Density of solution is gram per ml is a unit for the density of the solution. Density of the solution is equal to weight of solution in grams by volume of solution in ml, right? Clear? If you take volume of the solution to the left hand side and the density to the right hand side, then what it will happen? Volume of solution in ml equal to weight of solution in grams by density of solution, right? Density of solution. Clear? Then volume of the solution in the ml, if I substitute here this term, if I substitute here, what it will happen? Clear? Now what it will happen? Now we'll see what it will happen. Now, W by V percentage will be equal to weight of solute in grams by weight of solute in grams by weight of solution in grams into density of solution into 100, or else better we'll write in this manner, into 100 into density of solution. Clear? This formula where we have seen weight of solute in grams by weight of solution in grams into 100. Just now we have seen here, right? Weight of solute in grams by weight of solution in grams into 100. Clear? So can I convert this formula? Weight by volume percentage is equal to weight by weight percentage into density of the solution. This is very, very important. Clear? Repeatedly in the questions, if you remember this formula, we can interconvert the formulas very fastly. Clear? Now you say me, this is temperature dependent or temperature independent? What I said, if you see the volume term in the question, in the formula, that is temperature dependent. Blindly believe that is temperature dependent. Clear? This is a temperature dependent. Clear? Next term we are going to see, that is next concentration term we are going to see W by V percentage. What is the meaning of the W by V percentage? That is volume of solute in ml by weight of solution in gram into 100. Clear? Done. This is temperature dependent, because we are having the volume term, right? Temperature dependent. If they ask the units will be ml per grams. Clear? Now next, very most important formula that we are going to see. This is very, very important, and the next formulas that we are going to see, in that formulas it will play very, very crucial role. Clear? Now here, that is which one? Strength of solution. Clear? What is the meaning of the strength of the solution? Let's suppose I was taken the 1 liter of the solution. Clear? 1 liter of the solution I was taken. This is 1 liter of the solution I was taken. In this 1 liter of the solution, I was added some amount of the solute, means in the 1 liter of the solution, how much amount of our solute it is present, that we call it as a strength of the solution, So what is the formula for the strength of the solution? Strength of the solution is equal to weight of solute in grams by volume of solution in liter, clear? Now this can I modify? Can I modify this formula? How I can modify this formula? Now you see, weight of solute in grams by volume of solution, it is present in the liter, right? I want to convert this into the ml. ml means here it will become 1000. Weight of solute in grams by volume of solution in ml into 1000, right? Clear? Now this is a which one? Weight of solute in gram by volume of solution into ml into 1000. For our mathematical calculation purpose, can I write like this? Weight of solute in grams by volume of solution in ml into 100 into 10 into 10. Can I write like this? Same, right? If I write 1000 in this manner, above and below will be same, right? Now where we have seen this formula? Just now we have seen this formula, right? What? Weight of solute in gram by volume of solution in ml into 100 So can I write this formula? Is equal to weight by V percentage into 10. Clear? Now this we are going to use. In the which one? When we are going to relate it with the another concentration term, that is a molarity. Clear? With the molarity and the normality, we are going to relate it the strength of the solution. Clear? Now done. This is very important formula. Strength of the solution. Clear? Now next we are going to see another concentration terms, that is parts per million. Clear? What is a million? Here million means 1 million. 1 million will be equal to 10 to the power 6, and 1 billion will be equal to 10 to the power 9. Fraction will be equal to 100. Percentage will be equal to 100, and the fraction will be equal to 1. Clear? 1 million will be equal to 10 to the power 6, 1 billion will be equal to 10 to the power 9, and the percentage will be 100, and the fraction will be 1. So what is the parts per million? Now what is the meaning of the parts per million? Now you see, here the number of parts of definition. Number of parts of solute present in 10 to the power 6 parts of solution is called ppm. Clear? Now you see, what does this ppm is saying? Clear? Here some number of parts of solute that present in 1 million of solution. 1 million of the solution, this small amount of the solute is present. That we call it as a parts per million. So where we use this parts per million in our daily life, 1 ppm of the fluoride or fluorine will be good for our health. If you increase the concentration of the fluorine to the 1.5, what it will do? It will spoil our teeth or tooth. Clear? Here it will, our bones also, it will be spoiled. Clear? If you increase 0.5 concentration of the fluorine, so 1 ppm is good for our body. 1 ppm of the fluorine. If you increase it to the 0.5, it is bad to our health. Clear? Means, what is the ppm formula, or ppm we can say number of parts of solute by number of parts of solution into 10 to the power 6 into 10 to the power 6. Clear? Now another one term is also there, that is ppb. ppb. What is the meaning of the ppb? Here we have taken the 10 to the power 6 parts, right? There we have to take the 10 to the power 9 parts. That is a 10 to the power 9 parts. Clear? That is a ppb and this is a ppm. Clear? Now by this I want to stop the lecture. Why? Because why I want to stop this lecture here? Now next class, up to now some concentration terms we have studied. Weight by weight percentage, V by V percentage, clear, and W by V percentage, and some strength of the solution and the parts per the mils. And the next class what I will do, the very important the concentration terms we are going to see, that is molarity, normality, molality, clear, mole fraction, clear, and those interconversions between them, that will play a very crucial role in the calculation part of our questions in the solution chapter. Clear? In the next video or in the next lecture, we are going to study very clearly about those concentration terms, as well as which one, as well as their interconversions, how it will be helpful for us in the calculation purpose I will explain. Okay, now see you in the next lecture. Bye.